Now, getting into the things that come from the textbook, any rational number when it's written as a decimal either has a terminating decimal, which means that it comes to an end, like 3.58. There's no numbers following that. If I put any numbers following that, they'd all be zeros. I usually drop them anyway, unless I'm talking about significant digits in some science courses. When I see 2.7 with a bar above it, that means 2.777777. So it's a repeating pattern. As long as I have a decimal that either terminates or has a repeating pattern, I can write it as a fraction. I can write it as a rational number. Whereas if I don't have that repeating pattern, I kind of lose that ability to do so, and that's how we talked about irrational numbers. So these two are rational numbers here, and what I'm going to do for part C is going to be rational as well. So how do I go about doing this? Well, A is kind of easy because, the terminating decimal is just, basically you want to, get an idea of how that 3, 5, and 8 would not have a decimal place anymore. So, you kind of vision this, okay, well, that's like having 358 divided by 100. That's what moved the decimal place 2 spaces to the left, dividing by 100. So to move it to the right, that's, what I had originally. And I could always simplify that. 179 over 50. And oftentimes when they ask you to do this, it's okay to leave it as, an improper fraction where you have a bigger numerator than a denominator. We again, in upper level mathematics, we tend to shy away a little bit from the mixed number usage because there's some confusions about what a mixed number is as compared to some of the rules we talk about in math, and what the main one being that if I have essentially two quantities next to each other, it usually indicates a multiplication. So students will sometimes think 2 and 1/2 means 2 times a half, which it isn't. It's 2 and 1/2. It's more of an addition than a multiplication, and I've seen students do that. So they tend to shy away from, an advanced math curriculum from going to that mixed number unless it's absolutely necessary. But as I said, terminating decimal is not too hard. It's just basically moving the decimal place, beyond to the end, so you no longer have any more decimal places. And then it's like basically trying to figure out, well, how will I move that? When I have a repeating decimal, no matter how many spaces I move that decimal point to the right, I'm going to have more 7s to the right of it. Because, as I said, this is like having 2.7777 forever and ever and ever. So I just can't think of what I need to multiply this by to get, the decimal point moved so far enough to the right that I have no more 7s. Well, that's impossible because I have an infinite number of 7s. So I have to come up with a method of being able to decide or come up with this fraction value. So we start with defining n as being the number we're looking for. Now we eventually want to write n as an improper fraction. So I write out the number and I say, okay, well, I have the repeating pattern of 7. So if I were to take this number n and multiply it by 10, I'd have 27.777. So I basically have that same infinite number of 7s to the right. And that's the crazy thing about infinity, Me getting one of those 7s moved to the left side of the decimal place does not mean I have less 7s to the right. I have just as many 7s to the right now as I did before. That's something that sometimes when students try to think about that too much, it blows their mind. But the idea was to make sure that I got two numbers that had the exact same repeating pattern to the right of the decimal point, which I now have. Because what I can do at this point is I can subtract them. So if I do 10n minus n, I would get 27 point repeating 7s minus 2 point repeating 7s. When I carry through the subtraction on the left, I get 9n. When I carry through the subtraction on the right, I just get 25. The repeating pattern of 7s after the decimal point disappears. That's why it was important to get the exact same pattern of numbers that follow the decimal point in both numbers. Because that means that the decimal portion will disappear when you carry through the subtraction. So I now know that 9n equals 25, and then solving for n again, because n is the number I'm actually looking for, I get 25 over 9. And if you put 25 over 9 in your calculator, you do get 2.777. It might end with an 8 because they're rounding off on the screen, but it is 2.7 repeating.